We did look at page 151. We looked at those functions that could be differentiated without the chain rule and then those that require the chain rule. If you have sine of plain old x, that doesn't take the chain rule. But if you have sine of 5x squared plus 7, that's not just sine of plain old x. That takes the chain rule. Square root of x does not take the chain rule. Square root of ducks and pigs does take the chain rule. So look at those again if you need to. And then here's the best way I have found to write the chain rule. The derivative of f of ugly is f prime of ugly times the derivative of the ugly. Now this is leading us to what I spent my birthday doing. The general power rule, if you have ugly to the n, you can still bring the exponent out front. Same old ugly, subtract 1 from the exponent. But then you also have to have the derivative of the ugly. Now to convince you that the chain rule, the product rule, and everything you learned in algebra is true, I've done the same problem 3 different ways. The first way, y equals 2x plus 3 cubed. You could either use binomial expansion if you know it. That's not calculus, that's algebra. Or you could write down 2x plus 3 times 2x plus 3 times 2x plus 3 and multiply it all out. Either way, this is what you would have when you multiplied out that expression. Haven't done any calculus yet. All I've done is multiply a binomial times a binomial times a binomial. But writing that way makes it easy to differentiate just by using the power rule, term by term. And then I use the product rule, but the product rule is kind of ugly when you have 3 factors. You have to say the first factor, or the second and third factors times the derivative of the first and third factors times the derivative of the second, and then whatever's left times the other one. I can't even keep up with it. But you come up with the same answer using the product rule for 3 factors. The chain rule is so much better. Even though chain rule might make you cry sometime in the next 48 hours, it's better than the alternative. This is not just x cubed, it's ugly cubed. So the derivative of ugly cubed is 3 ugly squared, but then you have to multiply that times the derivative of the ugly. The derivative of the 2x plus 3 is 2. Distribute, and we get the same answer we got just using algebra or the product rule. The chain rule was faster. All right. Now, the words ringing in my ears yesterday or Wednesday as y'all worked out, the words in my head were, but what's the ugly? I don't get the ugly. What the heck are you talking about, ugly? Well, if I give you y equals, let's say 2x plus 3 to the 6th, then the ugly is what is being raised to the 6th power. I've got about 7 examples to do. When you see this, here's what I want you to think. Now that you know what the ugly is, this is the ugly. This guy is also ugly. I think it is. He's got a beard, and it's easier to glue on pigtails than it is. Yeah, I don't know. It's ugly either way. The derivative of ugly to the 6th by the general power rule is 6 times the same old ugly times the derivative of the ugly.
They probably think they look good.
I tried not to pick anyone's relatives. But if your cousin shows up, I'm sorry. The derivative of ugly to the 6th is 6 times ugly to the, oops, I almost left off something, 5th, just by the power rule, and then the derivative of the ugly. So can we do the same thing right here? Make sure when you start the calculus, you write your expression as y prime. The derivative is y prime. 6, same old ugly to the 5th. Times what?
2.
Derivative of the ugly is 2. And then simplifying that as much as possible, that's 12 times 2x plus 3 to the 5th. All right?
Do we need to take it up to do that 2x plus 3 to the 5th and work it all out, or just do?
Oh, heavens, no. No, because the goal is factored completely as possible. And this is factored, whereas if I wrote it down 5 times and multiplied it out, it wouldn't be in factored form anymore. So this is factored form. That's what I want. All right. Through with that, guy.
That's the answer?
That's the answer. Awesome. What about this one? When you see that, here's what I want you to think. The derivative of negative 3 times the 4th root of very ugly. How can you rewrite that before you do any calculus? You could write it as negative 3 ugly to the 1/4. Right? And then what would the derivative be? Negative 3/4. Same old ugly. Do the what? Negative 3/4. You're subtracting 1 from the exponent times the derivative of the ugly. Only in the place of the ugly, you really have a 2x plus 3. Here's how you're going to have to write the derivative of the 2x plus 3. But really, it's easier to not write that down and just say the derivative of the 2x plus 3 is just 2. So this is the same thing. I'm going to write that as negative 3 times ugly to the 1/4. And then the derivative is 1/4 times negative 3, or negative 3/4. Same old ugly to the negative 3/4. And then the derivative of the ugly. And then simplify that as much as you can. Negative 3/4 times 2 is negative 3/2. And I can put, oh, why did I write it? There's a typo right there. I found by saying, is that a line equivalent to what's on the line above it? That was 2x plus 3, not 2x plus 4. And you can put that factor in the denominator since it has a negative exponent. So that would be negative 3 over 2 times 2x plus 3 to the positive 3/4. Any questions?
Yeah.
John?
3 times. Okay. So that just went down because of the negative exponent.
Correct. And that was legal because this was in factored form. If there had been a plus something something out there, then I couldn't have brought that to the denominator unless I could factor it out. So far, so good?
I think so.
Okie dokie. All right, knock it off. When you see that, I want you to think of Nick Nolte. Most famous celebrity arrest photo ever.
I don't like the E either. Can that be part of it?
No, E is a number. If y is e to the ugly, then y prime is what?
The same thing.
Just tell me what to write, please. I'm not going to write the word same thing.
E to the 2x plus 3.
E to the Nick
Ugly.
Nolte,
Ugly. Yeah.
e to the same old ugly, and then what? Derivative of the ugly. So if I have e to the 2x plus 3, and I differentiate it, I'm going to get e to the same old ugly, and then the derivative of the ugly is just 2. A common mistake I see people make, instead of keeping e to the same old ugly, they'll have e to the derivative of the ugly. And that's not right. It's not just e squared, it's e to the same old ugly. All right. I'm going to switch gears, and instead of 2x plus 3, what if,
On that one?
Yes, sir.
If you would go to, for the second prime,
Mm-hmm.
would it just be 2e to the 2x plus 3 times 2 again, so end up being
Yep.
4e to the
Yep. Number 4. What if I had y equals secant, let me make this one more interesting. What about secant of 3e to the 2x? Ooh, that's interesting.
With. That's what I feel about that.
Get that one off.
That's secant ugly.
Yeah.
What's that off of?
What's-
That's off of who?
The internet. Not my family photo album. What's the derivative of secant ugly?
Secant times tangent.
Secant ugly,
Look at you.
tangent ugly, and then what? I had so much fun on my birthday. Yeah, it's secant ugly, tangent ugly, derivative of ugly, whatever the ugly is.
Miss Smiles, you're
So-
definitely a nerd. No, I'm just kidding.
What did you say, Kayla? I didn't hear you.
I said you're definitely a nerd.
I
and
am
this is
most
your birthday.
definitely a nerd. If you don't believe me, you ought to see me try to catch a baseball
Yeah,
with my face. This is derivative, this is secant ugly. So y prime is secant ugly, tangent ugly. Then what?
The derivative of
Derivative of the ugly would be what?
your version of that guy.
3e
Ooh,
to the 2x.
ooh, chain rule inside the chain rule. Look at that. Because this is not plain old e to the x, it's e to the 2x. So not only are you going to have a 3e to the same old ugly, or by the time you get to the second ugly, you just have to call it bugly. This is 3e to the bugly times the derivative of the bugly.
Miss Smiles, we can't see it. Can you like pull it down?
Oh man,
What are you saying?
what am I saying?
There
What,
you go.
You've never heard bugly before?
Now, what's that mean?
I made it up. I can't think of anything to do there other than multiply the 3 times 2 and put the monomial out front. I'm certain that in the back of the book that would be written as 6e to the 2x times secant ugly tangent ugly.
Do you have to split the secant and tangent up like that?
How would you write it that wasn't split up like that? How else could you write it?
You really couldn't. I mean, secant tangent. Not arguing.
Oh no, that wouldn't mean, you know what that would mean if you wrote it that way? Wouldn't mean the same thing at all. That would mean secant of tangent
Oh, okay.
e to the, or 3 e to the 2x. That's a totally different critter.
Ms. Miles,
Yes,
Put the
yes, ma'am?
3 in.
okay, so why wouldn't it be 6x? Because 2x times 3 would.
I don't
why
have
would it
2x times 3. I just have 3 e to the something times 2.
be- Okay, where are you getting the 2 at?
Derivative of that, just like on the previous problem when we had e to the 2x plus 3, the derivative was not only e to the 2x plus 3, but we also had the derivative of the ugly. Same thing here. This was 3e to the ugly. The derivative of 3e to the ugly is 3e to the ugly times the derivative of the ugly. Miss Kayla, is that okay?
No, I'm still confused.
I don't get it either.
Maybe
Because I'm thinking derivative is take 2x and multiply it by 3.
What would you do with it?
Yeah.
Oh my goodness, Kayla, I know what you're thinking. I know what you're thinking now. You're thinking if you had 3e to the 4th, multiply the, guys, please don't talk while I'm talking. Multiply the 4 times the 3 and subtract 1x from the exponent. You're thinking
Yeah.
power rule, Kayla? Let me tell you
Yeah.
2 reasons. Let me tell you 2 reasons that won't work. Number 1, this is just a constant. It's about 240. The derivative of 240 is 0. So you can't apply the power rule to e to the something. The rule for the derivative of e to the x is just e to the x. The rule for e to the ugly is e to the same old ugly, here's the ugly, times the derivative of the ugly.
Okay.
So the power rule just doesn't apply there.
Why do you have 2 derivatives there, though?
2 derivatives?
Yeah, 3e to the 2x and then times 2.
Because I had double uglies. Yeah, look right here. This was not just secant e to the plain old x. If it's not e to the plain old x, I'm going to have to use the chain rule for secant of this guy. And then once I've differentiated secant of ugly, secant ugly, tangent ugly, I have to differentiate the ugly, which was
Okay.
this guy.
So the derivative of e is its exponent, not.
No, that's not right. Don't say it like that, Kayla. The derivative of e to the x is just e to the x, but the derivative of e to the ugly is not just e to the ugly, it's also times ugly prime.
Okay.
So 3e is not the ugly part.
If it was 3e to the 2 without the x, then it would be 3e to the 2 times 0, right?
Yes, because 3e to the 2 is just a constant, and the derivative of any constant is 0. Miss Chastity?
Can you just let 2x be the ugly? Or
You could, well, not really, because in the beginning you weren't just taking the secant of 2x. You were taking the secant of 3e to the 2x. So this is my original ugly, but after I differentiated secant ugly, tangent ugly, I had an ugly inside the ugly. And this is why I'm saying, or it's what's hard about the chain rule. Not that this first problem was difficult at all, but it's when you have a function within a function within a function, and one of those is a quotient, and one of those is a product, and one of those is trigonometric, that you're going to think about changing your major to PE, just like I did. Keep going, you'll be glad you did. But you cannot, going back to last night or the homework I handed back, you will not get through this class by having some work and then copying the answer out of the back of the book and not knowing how you got there. It just won't work. It's worthless. Don't even write that down. If you can't explain it, don't even write it down because you don't have, you don't get it. You're going to have to spend some time in my office or some time in the learning center. Calculus is just that way. Or time with a buddy who already knows calculus. Any one of those three things is good. All right, we need to move on past secant ugly. What about, I have a new rule for you, and it's on the handout. We have talked about the derivative of e to the x. What we have not talked about is derivative of natural log of x. So new rule straight out of the book. We could prove this by the definition of logarithm if we wanted to. No thanks. I'm just going to memorize that the derivative of natural log of x is 1 over x. Every time. Now, what if instead of natural log of x, it was natural log of, guess what? Ugly.
Do 1 over ugly.
Not only 1 over ugly, but also times ugly prime. Y'all are getting it now. All right?
So
2 more rules, and these are the last two derivative rules you'll memorize for a long, long time. Maybe the rest of the semester. We've had the derivative of e to the x, but what if the base was something else? What if it was 5 to the x or cal to the x? Natural log of a times a to the x. Let me show you how that relates to the derivative of e to the x.
is 2 supposed to be wrote down as natural log of a to the x? Because where do we pull that natural log from like that?
I'm telling you the formula that you're going to use to differentiate anything to the x. Now, what if that anything was the number e? E is not a variable, e is a number. If this were e to the x, and I was using that rule to take the derivative, I'd say it's same old e to the x times the natural log of the base. What is the natural log of e? 1, and that's why the derivative of e to the x is just e to the x. But if I have any other base, if I have derivative of 5 to the x, then I don't just get the same old 5 to the x, I also get what? Natural log of 5. If you want to know why, then you're going to have to hang around after, and let's do this by the definition of the derivative. The limit as h goes to 0 of f of x plus h minus f of x over h. If you don't want to do that, then memorize this. And then the very last one, derivative of, well, we've done the derivative of natural log of x. That's log base e. This is for log base anything else. The derivative of log base anything of x is not only the 1 over x, but you also need natural log of the base in the denominator. Yes, sir. Okay. All right. Under that, we have, okay, hang on one second. We have the generalized versions of those. If we have not just a to the x, but we have a to the ugly, then the derivative is going to have to be same old a to the ugly, same old natural log of the base, but also multiplied by the derivative of the ugly. And then the same thing for log base a of ugly. You not only have 1 over ugly, you have to have natural log of the base times the derivative of the ugly. Yes, sir?
Why did you go from log of base to log base x to natural log base?
I don't.
03. You have the derivative of log base x equals 1 over the natural log. How did that switch?
That is what I would have to show you by the definition. You're asking why is this true, and all I can say is it's true because if you use the definition, it'll take you 2 pages, but this is what you'll end up with. Anytime you differentiate log base a of x, you're going to get the same old 1 over x times the natural log of the base.
But the 1 over x was for the natural log of x, wasn't it?
Yes?
So is it the same rule for log too?
Let me show you one more thing and see if this clears it up, and if it doesn't clear it up, we're going to have to talk about it later. What if I applied this rule to natural log of x? All right, according to number 1 over there, what's the derivative of natural log of x? 1 over x. Just because I have it memorized or because I took 2 pages and did it by the definition and that's what came up. Now, what if instead of using this rule, we had used this rule, would we get the same thing? Well, derivative of natural log of x, I'd have to think of that natural log of x as log base what? E of x. And according to this rule, I would have 1 over x times the natural log of what? What is the natural log of e?
So
They work proof.
It works for base e. This is for base anything.
You know though that the a to the x is base e.
Oh, I don't. I said, wait, which one are you talking about? You're asking me why a formula is what it is, and it would be like asking why is the quadratic formula x equals negative b plus or minus square root of b squared minus 4ac over 2a. I could show you, but it would take half a day, or you just memorize it. So yes, I mean that's not just hocus pocus made up, but I don't have time in class to do, the limit of h goes to 0, blah, 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 blah. All right. Whew. Oh, wore me out. I earned that paycheck. So, what about on our list? I'm almost retroactively. Guys, I am going to hurt you.
I'm very sorry.
I'm not even kidding now. You have crossed the mama line. If you can't sit there without playing, you got 2 choices. Separate or leave. Got it?
Yes, ma'am.
All right. Number 5. If you had y equals natural log of, let's say, making it bad again because it's coming in tonight's homework, sine of x. Natural log of sine of x. Natural log of ugly. The derivative of natural log of ugly is 1 over same old ugly times what? Derivative of the ugly. So if the ugly is sine x, then y prime would be what? 1 over sine x times cosine x. Hey, what's that? That's not going to be the answer in the back of the book because that's more simply expressed as cotangent x. How about that? The derivative of natural log of sine x is cotangent x. Yes, sir.
So, now we're doing the derivative of natural log of sine x.
Uh-huh.
Okay, that's gonna be 1 over x, but we still have to multiply it by the derivative of sine x.
Said it beautifully, yes. And the
Yeah,
derivative
but
of
we-
sine x is cosine x.
Do we do that because of the chain rule?
Exactly.
And the chain rule applies all that stuff down there.
Anything that's not just a plain old x is going to take the chain rule. Natural log of plain old x wouldn't take the chain rule. Natural log of anything else is going to take the chain rule.
Okay.
It was 2x, would it?
Natural log of 2x, yes. You would not only get natural log of 2x, but you'd also get what?
Times 2.
Times 2. That's right.
As a thought,
Yes, sir?
even if you did the natural log of x and used the chain rule with it, it would still come out the same because the derivative of
yeah.
x would just be 1.
That's the beauty of math. It does, I mean, the rules never change. Let's play like, that was a good point. Let's play like I did just have simply y equals natural log of x, and I just wanted to use the chain rule on everything. Just like you can use the quadratic formula on everything, but there are easier things. Then I would say 1 over x times, what's the derivative of the x?
1.
You're absolutely right. That's still just 1 over x.
What would be the easier way to do that? Not
There-
using the chain rule.
Just memorize derivative of the natural log of x is 1 over x. Add it to your list of things that you will have memorized after 3.4 for sure. All right, number 6. This reminds me of the problem I worked for some of you before class. Some of you had trouble finding the second derivative of 97 on the homework. This is what you came up with for the first derivative, and then because you didn't know the chain rule yet, you had to FOIL that out before you could find the second derivative. Well, if only I had known the chain rule last night, it would have been much easier. I could have written that -1 over x minus 1 squared as this, and then I could have just used the chain rule. So, similarly, that's -8 over ugly cubed. How do you want to rewrite it?
-8 times ugly to the negative.
-8 ugly to the -3. And that's not the derivative, that's just rewriting the function. So what would the derivative be?
Negative, I mean, positive 27.
24, close enough. Then what?
X minus 7 to -2.
Boy, you just refuse to say ugly, don't you? I've broken other people. I've had other people refuse to say ugly, and by the end of the semester, they loved ugly. Subtract 1 from the exponent, and then the derivative of the exponent. The derivative of -8 ugly to the -3 is positive 24, same old ugly to the -4 times the derivative of the ugly. So what if the ugly is 5x minus 7 cubed? It would be 24 times what?
X minus 7.
Same old ugly, whatever it is, to the -4 times derivative of the ugly is 5. And then simplify that as much as possible. That's 120 over 5x minus 7 to the 4th.
If you left it 5x minus 7 to the -4th, did you count that wrong?
Partially, because our goal is write as a single fraction, factored as completely as possible, no negative exponents. Because of what's coming later. later we're going to set that equal to 0, and that's easier to do if it's in that one single fraction with no negative exponents. All right, last one. And you're allowed to think right now that I'm just being silly, but this is what's coming in the homework. I'm trying to prepare you for it. What if I had y equals sine of, let's say natural log of x cubed times sine of 4x minus 7.
Use the product rule first.
I would have the product rule, and I would have the chain rule inside the product rule. That is equivalent to this. You know what? Let's not make it terrible yet. Leave it just 5. That is 5 ugly cubed times the sine of ugly.
I was gonna ask if you could factor out the sign of everything.
Tell me how.
Yeah, you could.
No, yeah, you're right, you couldn't. This guy that looks like he's wearing camo, that's all body hair. It's horrible. So is that woman eating a banana. So, the derivative of 5 ugly cubed sine ugly, or I can't use ugly for both of those because they're two different things. That's where this is ugly, oops, which ends with a y, and this is, for lack of, ugly. All right, let's take the product rule. The derivative of a product is the first factor. What's the first factor?
5 natural log x cubed.
Did somebody say natural log? 5 ugly cubed.
Not bad.
That's the first factor. What's the derivative of the second? Cosine of
4x minus 7 times 4.
You can't get over the 4x minus 7. That's 5 ugly cubed, cosine ugly, but not only cosine ugly, what else? Ugly prime. Plus, that's just the first half of the product rule. Then what? Second factor. The derivative of the first. What's the derivative of the first? By the power rule. 15. Same old ugly. Squared. Times what? Ugly prime. Just almost doesn't fit there, but yes. Do the same thing with, I've lost it. Where did I put that piece of paper? What was it originally? 5 times what?
Natural log of x to the third.
No, I didn't have 5 times natural log of x.
5 times natural log of x.
Oh, I did. Oh, here it is. First factor times the derivative of the second, which is what? Cosine
4x minus 7 times
4x minus 7 times 4. And I'm using dots there just to keep myself from later distributing that 4 in some crazy way saying that's cosine of 16x minus 28. I don't want to go there. That's first times the derivative of the second, and the derivative of the second is cosine ugly times the derivative of the ugly. Am I through? That's the first half of the product rule. Then plus what?
15 natural log of x to the 2.
Okay, doesn't matter which order you say it. I was thinking second term times the derivative of the first, and you're right about the derivative of the first. That's 15 natural log of x squared times the derivative of the ugly is 1 over x.
So the 2 doesn't come with that.
Which 2?
Out of this. The 2, the exponent 2 of natural log of x. That's not part of the ugly this time.
Right. This was 5 ugly cubed. The derivative of 5 ugly cubed is 15 same old ugly squared, and then the derivative of the ugly. Now, because I made that up, and it's horrible, there's not much cleaning up you can do there. You can't write that as well, you could, but I wouldn't ask you to. Write that as a single fraction, simplify it as much as possible. All I would reasonably expect you to do there is write the first term as 20 times the natural log of x cubed. Would that be the same thing without parentheses? Absolutely not. It would just be the x that was cubed, not the natural log of x. So you need those parentheses times the cosine of 4x minus 7. And there's not much at all you can do to that second term.
Plus 15 over x times.
Yeah, I was going to write that x in the denominator. Yeah, all over x. Or just the 15 over x, it would mean the same thing.
That's next.
Yeah, that's pretty nasty, but that's because I made that problem up. I didn't make it up where it would clean up nicely. Yes, sir.
What would it be 4 pi ln x cubed times 4 cosine?
I'm looking.
In the second step.
This is step 1. This is step 2. This is term.
I mean, step
Okay, so in step 1, what are you saying?
it was, what would it be 4 cosine of x minus 7?
It is. I just put the 4 at the end with the derivative of the ugly. It's the same thing and actually would look better in front. Either way, I ended up multiplying by the 5 in that step.
We left it 15 ln of x squared times 1 over x. Would you count off, or could we leave it like that?
I wouldn't give you anything that ugly on the test. I would give you something. There have been times on a test that I've said you don't have to combine terms. And when I've said you don't have to combine terms, it's because it's kind of that bad. I can think of one problem on one test where I've just said, don't worry about simplifying this, just find the derivative. All right, so let's see if we can do some more in the book. From page 181, I'm not going to write the first few down. We're just going to talk through, and then when it gets too hard to talk through, we will write. Number 14, that's ugly to the 2/3. What's the derivative of ugly to the 2/3? 2/3 ugly to the negative 1/3 times derivative of the ugly would be 9. All right, no problem. Number 20, that was one of the ones that I made up with different radicand there. 24 was one of the ones that I made up. You'd write that as what before you differentiated it?
-8 times t plus 3 to the -3.
Exactly. -8 times t plus 3 to the -3, and then you just use the generalized power rule. Maybe we ought to look at number 26 written down. Something else you need to do in the homework if you're not already doing it is writing down the original problem. It's one of those things math teachers say and you think, why bother? But see what you make on a test compared to someone who writes down the original problem, and that'll answer your question. All right, there's some rewriting to do here before I use any calculus. How can I rewrite that?
Fraction to 1/2.
All right, I can do that. Big ugly fraction to the 1/2. Now, if I leave it at that, I'm going to have to call this my ugly, and the derivative of ugly to the 1/2 is 1/2 ugly to the -1/2. And then I'd have to take the derivative of this ugly using the quotient rule. Is there a way that I can avoid using the quotient rule?
Yeah.
How?
Get the t squared minus 2 out underneath the fraction.
How?
On the top of the -1.
Put it to the -1, and then I'd have -1 to the 1/2.
Yeah.
Why don't I go ahead and multiply those and say that's just t squared minus 2 to the -1/2. I've just made the calculus much easier. I haven't done any calculus. I've just rewritten the problem. And now the derivative. This is ugly to the -1/2. Derivative of ugly to the -1/2 is 1/2, -1/2. Same old ugly to the what? -1/2 minus 1 is -3/2. And then what? Derivative of the ugly would be 2t. If you left that, most definitely I would count off. That's not how you need to leave your answer. How does it simplify, Miss Chastity? Yes? I'm going to go ahead and do that in one step just so I don't have to rewrite it again, but you're absolutely right. The -1/2 times 2t is -t. The binomial to a negative exponent will come downstairs with a positive exponent. Um, 30's gonna be medium ugly because we have to use both the product rule and the quotient rule. But on that last example I made up, we used the product rule and the quotient rule. So I'm gonna skip on to something else. Next ugliest thing I see is 32. Could I write that so that it's not a quotient? Absolutely. But would it really be any better? I'd still have to use the product rule, and maybe you think the product rule is easier than the quotient rule, but it's harder to clean up. So don't worry about rewriting that as a product. Just rewrite the radical as an exponent. The derivative would begin with what? Denominator times the derivative of the numerator. Good. Then what?
Minus numerator.
The numerator times derivative of the denominator, that's going to take the quotient rule. I'm sorry, not quotient rule. That's going to take the power rule, because it's not just x to the 1/2, it's ugly to the 1/2. I'm going to use brackets for that. Not only are you going to get good at parentheses, you're going to get good at brackets. How do I differentiate ugly to the 1/2? 1/2, same old ugly, to the negative 1/2 times what? Derivative of the ugly is 4x cubed. Is that all? Oh, over the denominator squared.
Will that cancel out?
Let me write it down and we'll see. It depends on what you mean by cancel out. What do you mean by cancel out?
We'll take the exponents by.
1/2 times 2 is 1. I hate to say something cancels out, but 1/2 times 2 is 1. That numerator is pretty darn ugly, but that's the kind of problem that I put in Momentum for you, an extra sheet of problems from the pre-calculus book. If you have this and then magically the answer from the back of the book, you're not getting squat next time. You can't do that and get the answer in the back of the book in your head. So let's talk about how to clean that up. I think I need to clean up this second term. Hey, in pre-calculus, I got my folks to breathe deeply and say, it's just a binomial. No matter how ugly it is, that's the first term, that's the second term, it's just a binomial. Clean up each term of the binomial as much as possible. First term of the binomial is already pretty cute. What's the second term of the binomial?
2x to the 4th
Yes,
times x to the 4th plus 2.
good. 2x to the 4th times x to the 4th plus 2 to the negative 1/2.
Wouldn't it be 3?
Let me double check. Wouldn't what be 3? X cubed? No, you got x cubed times this x right here.
Oh, I didn't even see that X.
Yeah. So far, so good? The most illegal thing you could possibly do right now is highly illegal canceling. Just whack that in one of those or half of that with, I don't know. You cannot cancel terms or parts of terms. You can only cancel factors. So what do we have to do next? Factor. I can factor out an x to the 4th plus 2 to what power? Lowest power is negative 1/2. When I factor out something that ugly, I know I'm going to have parentheses left. So I'm going to use brackets and then parentheses inside the brackets. If I factor that out of the first term, what's left? Let's see. X to the 4th plus 2 to the, did you say negative 1? Does negative 1/2 plus negative 1 give you 1/2? Oh.
You subtracted.
Well, to get that answer, you subtract this from that. 1/2 minus negative 1/2 is 1/2 plus 1/2.
I did it backwards.
Yeah, it's positive 1. But all you know, if you make a mistake, all you have to do is say, is that equivalent to the line above it? Check your work, and if it's not, you fix it. All right, that's what's left of the first term. What's left of the second term? Just the negative 2x to the 4th. Still over the denominator. Which doesn't really need parentheses, but I like them because I'm going to bring this x to the 4th plus 2 to the 1/2 to the denominator. And when I do and add the exponents, I'll have a positive 1/2 plus 1. I'm going to end up with x to the fourth plus 2 to the 3/2 in the denominator. And what's left inside the numerator, written as simply as possible. And if you combine like terms, I'd write it 2 minus x to the fourth. I can't believe I ever hated this stuff. It's awesome. All right. Number 34. When I look at that, that's what I really see. That's ugly cubed. What's the derivative of ugly cubed? Three, same old ugly, squared, times what? Derivative of the ugly is going to be really ugly. But here's what I'm expecting. 3 ugly squared. And what's it going to take to find the derivative of the ugly? Quotient rule. Quotient rule starts with the denominator times the derivative of the numerator, which is 6x. I wish I had left room to put the 6x in front, but I did not. That's the denominator times the derivative of the numerator. Now minus the numerator times what? Derivative of the denominator is 2. And all of that is over the denominator squared. If I'm going to write that as a single fraction factored as completely as possible, it may be useful to write this second factor as 3x squared minus 1 squared over 2x plus 5 squared. I'll tell you why, or you can probably figure out why. If I apply the numerator or the square to both the numerator and denominator, then in some later step, I can say that's just 2x plus 5 to the fourth in the denominator. Let's see what that second numerator cleans up to be. Oh, you're combining like terms? Yeah. I was checking my work before I went any further. I was making sure that was equivalent to the line above it. I'm so proud of you. I'll give you every penny's worth of credit there. But what else could you do?
You know, keep going and
Foil and add like.
top two.
Oh, no. I don't want to multiply out. I don't want to multiply. That's unfactoring, and I want my answer factored.
Factor the second,
You could factor a 2 out of that trinomial and multiply it by the coefficient 3. If the goal is factor as completely as possible, then you're not really through until you get here. 2 would be 15. Hold on just a second. Let me double check my factoring.
So would you not have to check if that trinomial factors?
Yep, but you know that only takes one question. If I multiply 1 times 3 and say, are there factors of 3 that have a sum of 15? No, there aren't. But I did check that.
But if it did factor, you'd go ahead and factor.
You would factor because that's the goal because of what's coming later.
Hey, Miss Miles,
Yes, ma'am.
would it have been easier to make it to where it's 3x squared, or we first started at the
Yes, ma'am.
problem? 3x squared minus 1 in parentheses times 2x plus 5 to the negative 1. Bring the 2x plus 5 to the top. And then
That
full
is
out.
legal. That is legal, but in my opinion, not helpful because you're changing a quotient to a product, and the quotient rule's not really harder than the product rule. The cleaning up would actually be uglier if you do it that way, Kayla. So I never change a quotient to a product. If I can't write it so that I don't have to use product or quotient rule, then I just leave it quotient. You can do one the other way and then you might agree with me. Or you might disagree with me. I don't care as long as you get the right answer.
Okay.
All right. Let's skip over to trying to see what's ugly now. 40. Let's do 42. Hang on one second before you do. I remember I circled the ones I wanted to do. Last one was 34. 58. Skip to 58. That looks easy compared to everything else we've done. It is easy. That's not just sine of x. That's, well, actually, is it? Is that? That's just like the sine of 3x, right? Pi is just a constant. But because it's not sine of plain old x, it's sine of 3x. When I differentiate, I not only have to get cosine of same old ugly, I also have to get what?
Derivative of that.
Times the derivative of that ugly would be pi. It would be better to put that pi out front. If you put it at the end, you might be tempted to say pi times pi is pi squared. So that one was easy as long as you go pi is just a number. Number 60. That's secant ugly. What's the derivative of secant ugly? Secant ugly, tangent ugly, times the derivative of the ugly, which is 3x squared. What about is important. I might have to write you a caution for this. Number 64. Big caution. Doesn't matter which trig function or what the exponent is. If you have, for example, sine square of x, to think of that correctly, you need to write it as sine x in parentheses squared. And that's what I need to do here. Without doing any calculus, I need to write that as 5 times cosine pi t, and it's that whole thing that's cubed. If you forget to do that, you're quite likely to miss it. That's just, oops, that one has a prime. That's just 5 ugly cubed. What's the derivative of 5 ugly cubed? 15 ugly squared. Same old ugly. That's 15 ugly squared. And then what? Derivative
Your conference is scheduled to end in 2 minutes.
is negative sine pi t. And then what? You had to have the derivative of that ugly as well. Not a whole lot of cleaning up you can do there. You have coefficients of 15 and negative and pi. I would write that as negative 15 pi cosine square pi t times sine of pi t.
Did you do that because that's how that problem was written initially?
Yeah, it's okay to keep the brackets, but now that I'm through, I put it back like it originally was. All right.